right, this is 4.2, number 25. We want the regions where this function is increasing, where it's decreasing. And so how are we going to do that? So part of the things that you have to know, where can a function change from increasing to decreasing? And you have to know it can only occur at critical points. Critical points are where the values of x, where the derivative is positive, excuse me, where the derivative is 0 or the derivative does not exist. So again, we're assuming we're starting with a continuous function, which we have here. Do it give us a domain on 25? They don't give us a domain, so we'll have to talk about that a tad bit. Okay, the domain of this function, you have to know how to find that. And if you look, it's going to be limited by this, the ln of x. And do you all know what ln of x looks like? Hopefully you know that it looks like that. It only exists to the right of 0. Therefore, the domain of this function is from 0 to infinity. So very important to look at that and to understand that. And it's continuous everywhere on its domain. But one more time, you need to know the only place where a function can change from increasing to decreasing, vice versa, is a critical point. It's critical that you know that. But just because you have a critical point doesn't mean a function will change from increase, decrease, and vice versa. But if it is going to change, it will happen at a critical point. Very important. So also, these things that I'm telling you, you should visually be able to picture why. It shouldn't be just straight up memorized, because that's going to be very bad this chapter. I'm telling you, it's going to be bad if you just straight up memorize these rules. You will get very confused because there's so many similar things but slightly different. So please, I beg you, make sure you understand why you do what you do. So when we do the derivative, you will notice product rule, because we're multiplying two things, and this is not ln of x. So that's going to be ln of box. You're going to have to use chain rule there. So the derivative, you leave the first alone, and you take the derivative ln of box. The derivative ln of x is 1 over x, so the derivative of 1 over, or ln of x squared, or ln of box, is 1 over box times derivative of box, which is 2x, plus you take the derivative of the first one, and you leave the second alone, and the derivative of 1 is 0. So there is my derivative. Let's do some simplifying. That x squared and that x squared cancel. So this is becoming very beautiful. We will notice that both of these have a 2x in it. So we factor the 2x out, and we're left with 1 plus ln of x squared. How nice is that? So to have critical points, I need to know when this is 0. This is never undefined other than on the domain of that, it's always defined. So on this domain, ln of x squared is always defined. So we're not going to have any undefined points. So our derivative will always exist. But we set each one equal to 0. So x equals 0. What's the problem with x equals 0? It's not part of the domain of the original problem. That point doesn't exist in the original problem. If that point doesn't exist, then it can't be a critical point because it's not even part of the problem. So that's gone. Here we'll subtract 1 from each side. Then how do you get rid of ln? This is your skills that if you don't have this is something you need to be good at. E is the inverse of ln, so E will cause the ln to cancel out. So now we're left with x squared equals e to the negative 1, which is 1 over e, however you wish you write that. Then we square root both sides. But when you square root, you need a plus or minus. x equals plus or minus square root 1 over e, which is plus or minus 1 over radical e. And here's the problem. Look at our domain. It's 0 to infinity. So therefore, the negative we ignore, and we only have one critical point. There is our critical point. So that's the only place where the function can change from increasing to decreasing or vice versa. That's the only place. So with that information, we are now able to find regions. I'm going to make a number line. This is 1 over radical e. Our left barrier was 0, and our right is infinity. And now we make a box. So picture this as a number line. That's what you should see. And you should know why we put x here and f prime. You shouldn't memorize, you put f prime there. Because in other future problems, we're going to put f double prime there. Why do we put f prime? What is our whole goal in this problem? Our goal is to find increasing, decreasing regions. You need to know what tells you increasing or decreasing. Again, this is another part that needs to be in your brain, and you can't even think about it. Like if someone asks you what's your name, do you like, oh, it's George, Fred, Brian, my name is Brian. You don't have to think about it. When I ask you, how do you know if a function is increasing, you should say because the derivative is positive. If that doesn't happen immediately, you're not ready, and you have to be ready for that. If I ask you, how do you know if a function is decreasing, you better say right away, the derivative is negative. And not only should you know that, you should be able to visually picture it. Here's a function. Look, the slope's positive. The derivative is positive. The function's increasing. Here, the slope's negative. The function's decreasing. You should have a visual picture, and you should just know that. So, why are we making this chart? Between 0 and 1 over radical e, the function is either always increasing or always decreasing. It cannot change directions because it only changes directions at critical points, and there's only one. So we need to pick a number between 0 and 1 over radical e. I think 1/2 fits that, and I'll tell you why I think that. And one bigger than that, so e is about 3. Radical 3 is about I can't remember now. Is it 1.7? And 1/2 is smaller than 1.7. Let me double check because I'm losing all confidence in my brain. And on the AP test, you won't ever have weird numbers where you have to figure out what's in between. So that's the good news. 1 divided by radical e is 0.6. So we're good. So 0.5 is smaller than that. And then 1 is bigger than that. So what's the derivative at 1/2? Well, I'm going to bring this derivative formula back down here. I'm going to copy and paste it because we're going to need this. So this is f prime. Well, if we plug in 1/2, ooh, this is good stuff. This is good stuff because there's a lot of weird stuff going on here. 1/2 times that is positive. 1/2 squared is ln of 1/4. Oh no, I don't think that's going to be negative. But is it smaller than -1? I don't know. I'm going to have to put that in a calculator. I'm going to have to cheat. But I'll show you why. You should know this is 1. ln of a number between 0 and 1 is negative. ln of a number bigger than 1 is positive. So that's stuff that you should know. I'm actually going to have to do this in my calculator. ln of 1/2, or 1/4 actually. ln of 0.25 is -1.38. So this is negative 1.38 plus 1, that's going to be negative. That's positive. So between 0 and 1 over 1 radical e, the derivative is negative. Then if I plug in 1, what's ln of 1? 0. 1 times 2 is positive. We know it's positive here. All we care if it's positive or negative, because if the derivative is negative, the function is decreasing. The derivative is positive, the function is increasing. So I don't have the exact graph, but I know it's decreasing from 0 to 1 over radical e, and it's increasing always after that. So now I know my regions of decreasing and the regions of increasing. Decreasing in this region, increasing in that region. So my final statement, FRQs, how do you write the answer? It's asking the regions for increasing, decreasing. F is decreasing on the interval from 0 to 1 over radical e. That's not it. You have to give a reason why. You need to justify why. The reason is because the derivative is negative on that interval. That's your reason, your justification explaining why. Then I would say f is increasing on the interval from 1 over radical e to infinity. Why? Actually, you can do BC. You could do because f prime of x is positive on that interval. And that is your explanation of where it's increasing, decreasing with a justification.